So worksheet 2, looking at number 4, 2 sine x equals 1. Remember, job 1 is to get the trig thing by itself, and then worry about unit circle. Pardon? So let's just jump to the end here, or not the end, but we can get the trig thing by itself without showing all the steps, I think. So sine of x equals negative 1/2. I needed to read the directions here. All the answers between 0 and 2 pi. So, yes, there's an infinite number of answers. I only want the ones between 0 and 2 pi. Some people don't draw a picture. I almost draw a picture on all these because it sort of helps my brain think about where's the sign negative. Well, it's in the bottom. Okay, my thing is sign's the up and down one, so sign's negative in the bottom one. Other people are thinking all students take calculus, so it's in the third and the fourth. Either way you think of it, you're in the third and fourth quadrant. So quadrant 3, quadrant 4. Again, you don't have to write that down. What about the reference angle? What about shallow, middle, steep? Where's the sine equal to 1/2? Is that the shallow, the middle, or the steep? That's the shallow. So shallow angle in third and fourth. And again, you don't have to draw the picture. I think it doesn't take much time, and it helps me think about where the answers are. So let's see. The shallow angles are all over 6. No, we're talking angles, so there's no roots involved. The angle is 7 pi over 6. And what about that fourth quadrant angle? Good. We have to go the long way around because we have to have our answer between 0 and 2 pi. So 7 and 11 over 6. And again, we sort of know in the back of our mind there's a lot of other answers, but those are the only ones we want between 0 and 2 pi. All right, let's look at number 8. Because number 8's got an extra 3 in there. I guess the big question, or the main way to ask this question is, when do we handle that coefficient 3? Like at the beginning or at the end? At the end. So we sort of pretend that that's just one thing. Actually, we do pretend that that's one thing, 3x. 3x kind of goes together. We'll fix it at the end. All right, tangent is negative in the second and fourth, however you want to remember that. So quadrant 2, quadrant 4. The tangent 3 trick means that this will be over 3, whatever it is. And over 3 is the steep angle. So 2 pi over 3, and whoops, not 4 pi over 3, but 5 pi over 3. But that's what 3x is equal to. Now, what do I do next? Right, I need to get some more answers. Don't divide by 3 yet. I need to get some more answers. So I need to add 2 pi, which is really 6 pi over 3. So that would be 8 pi over 3. How many times do I need to?
3 times, or you need to triple it.
I need, yes, triple it. It's a good way to say it. I need triple the number of answers. And then I need to add 2 pi over 3 to 5 over 3. So that would be 11 pi over 3. And then add 2 pi over 3 to that. Be 17 pi over 3. And now I've tripled my number of answers. I initially had 2 answers, now I have 6 answers. So I've got all my answers that I need. Again, the idea is I can keep going, but when I divide by 3, I want all my answers to be between 0 and 2 pi.
Would this be like one of the fill in the blank questions where it would be, because I feel like this would take a decent amount of time to try and do a bunch.
Fair question. So it's like how, yes, these take a little time. I don't know how it.
Okay.
Yeah, it can still be a multiple choice question, where we could just give you those. We could forget to divide by 3. So there's lots of good places to get distractor answers from. What's my final step here? Yeah, I've got 3x. I don't want 3x. I want to know what x is equal to. So divide by 3, but given what's on the right, it'd be much easier to multiply by a third. So all my denominators are now going to be 9. And look for ones that will reduce, although I don't think any of these reduce, so we're okay. Oops, 17 pi, yes. I was going to discover that error because I was just checking to see if that last answer was still less than 2 pi, to make sure I didn't go flying past. So 17 over 9, is that less than 2?
Yes.
Yeah, barely, but yes. So I'm okay. In fact, if there were more answers, we would be outside of 0 to 2 pi. So I think ones like 4, pretty easy. It's when there's a coefficient on that number, things get a little bit crazy. How about number 10? It's x over 2. Let's do number 10. So cosine of x over 2 equals root 2 over 2. Again, save the over 2 thing for the end. Like, save that for the last thing you do. Cosine is positive in the first and fourth. Root 2 over 2 is the middle one. So pi over 4 and 7 pi over 4. Now, how many extra answers? Like usually, if there was a 2 there, it doubles our number of answers. If there was a 3 there, it tripled the number of our answers. If there's a 1/2 there, it's going to... Actually, I don't want to say that because it may or may not. We need to be very careful.
Wait, does that mean times 2?
I definitely don't need to add any more. So let's times 2 and then see where we're at. Because sometimes it's going to cut the number of answers in half, but sometimes it's not. So let's times by 2 to get x by itself. So that would be pi over 2 and 7 pi over 2. Because the 2 and the 4 reduce. And I want answers between 0 and 2 pi. That means that 7 pi over 2, I don't need that one. That one's too big. But it doesn't always cut the number of answers in half. So you have to be careful on that one.
So what would happen
Like if this problem was sine of 2x, or excuse me, sine of x over 2 equals root 2 over 2, then that means x over 2 is pi over 4 and 3 pi over 4. And x would be pi over 2 and 3 pi over 2. And both of those would work.
Would there be a situation where it would be like pi over 3 or pi over 5? Something where you can't just divide it.
I mean, well, if it's over 3, then you would multiply by 2 in the top.
Yeah.
Yeah. So sometimes it cuts the number of answers in half, sometimes it doesn't. What it always does is cuts, well, I don't want to say that. That's kind of it for that worksheet, because 11, 12, and 13 are basically review from the first day. Just remembering, hey, put in the calculator, don't forget to do the second calc intersect, first graph, second graph, guess. That's what 11, 12, 13 are. Anything else on that worksheet? Number 6. Let's see. So if I move the cosine over, I get cosine of x. If I move the 11 over, I get 1. Right? Hopefully you're to the point now where you don't have to write out minus 11 on each side and do that as a step. And then write out minus 4 cosine x, minus 4 cosine x. Hopefully you can jump from there to there without error. Okay, cosine of x equals 1. Let's see. Cosine of x equals 1, right? Yeah, right there. So where is there? What's the angle there? How far have I rotated? 0 or 2 pi. And then, I guess be careful, but that fits, because it says between 0 and 2 pi. And it includes 2 pi. There are some books and worksheets that don't include 2 pi because they feel like 2 pi is a repeat of 0, so it's like, well, why do you include that's the same point. So you got to look closely. We're going with including 2 pi, but if it didn't include 2 pi, then obviously we wouldn't include 2 pi there. So that's just a variation from book to book, worksheet to worksheet.